Hi everyone, welcome to our project. In this project, we are going to do some analysis in our liquidity sites. Now let me introduce some background first. Our project was inspired by such a situation that when any business owner wants to open a new store or expanding his existing business at a new city or a new community, it can be challenging for him to decide on the best location and products that can bring more profits to him. Similar situation exists when vendors want to sell their products. Analysis is needed to check how products of the same time are doing in the market. Analysis on above questions are necessary when taking decisions on such as the optimal location for their business, what products they will sell, and how to increase sales when starting something new. Therefore, by examining the past sales data, our initiative intends to provide analysis on such questions to provide some insights and assist them in making profitable decisions. And we chose the Iowa liquid data site presented by Iowa government as an object to study. The above strategy is not limited to this particular data site. It can be extended to providing such analysis in other domains. Now let's take a look at the overall structure of the project. For the data collecting part, we developed two paths. One is the one-time downloading from the source, and the raw data is fed into a data cleaning pipeline to generate the tables we want, and then the tables are stored in Amazon S3. The other one is using Kafka to send the updated data into a same data cleaning pipeline, and then add into our data set. For the analysis part, we will develop an overview of historical sales data first, and then focus on three relatively complex analyses and visualize the results. This will be conducted on Amazon EC2. Finally, we've summarized them into a report and develop a GitHub page to display. Let's look into each section in detail. For the data acquiring and the cleaning part, let's click on this link for more details. The main data source is a 5.7 gigabyte file, Iowa Liquid. Through analysis, we found that this table contains store information, product information, and transaction information. There are a lot of redundant and wrong data in the store data side, such as information loss, multiple names for the same store, etc. In addition, the geographical location is stored as coordinate pointed data instead of latitude and longitude, and there are errors in the data format. In order to facilitate analysis and remove redundant and erroneous data, we use the official store table and product table to replace wrong columns from our liquid sales table. In this way, it also normalizes the data. After solving all the mentioned problems, the data becomes three tables of sale, store, and product. We performed this data cleaning operation on Amazon EMR. Here's some screenshots. Let's go back. For Kafka part, after acquiring the existing data, we'd like to consider how to update the data, as our government updates their data site at a regular basis. This analysis may be operated sometimes later, and it will cost a lot if we clear and reload the whole database. Therefore, we added two scripts for Kafka streaming. The first one is a producer. It runs at the background, creates three topics for the three tables respectively, keeps checking the source data site through Subdata API every night, and if it finds any new range of data, it streams the data to corresponding topic. And on the other side, there is a consumer keeps listening to the three topics and updates or appends the new data to our database. Let's move on to the overview and the question part. Before we dive into any deeper analysis, we would like to have an overview of the historical sales data and see whether there is a particular pattern of how the total sales change. Click here for more details. To show the trend, it would be better if the data is distributed on a fixed time interval, and we chose to aggregate it by month. Here's the curve we got. There's obviously a fixed pattern following which the sales fluctuate within each year, and the overall trend is increasing. And therefore, we are also interested in using some machine learning model to predict next year's monthly sales. We use the year, month, and amount of sales of the last year's same month as features, and gradient boosted trees as a regressor to train a regression model. The model achieved an R2 of 0.83 and gives such a prediction. Let's go back and move on to question 1. In this question, we explore what are the most effective ways to segment Iowa's liquor market. Click on the title to have more details. Roughly speaking, a market segment may have four stages: introduction, growth, maturity, and decline. Vendors may care about which market segments are growing fast or have the potential to grow. However, there are also so many ways to segment a market, and some of the segmentation scenarios may not reveal a variation, so that we cannot see which segments are worth investing or which are not. Therefore, we are interested in finding some effective segmentation scenarios. To do this, we firstly prepare some candidate scenarios. There are city, category which are existing, and low to high end and bottle size which we can derive according to computed unit price and bottle volume respectively. We use them together with all combinations of them as objective scenarios. We firstly process each table individually to get the mentioned features and join them together. Then for each segmentation scenario, we apply such an algorithm, which consists of selecting, self-join, computing, and aggregation to get the growth rates of each market segmentation under the scenario. Finally, we take the variance, mean, maximum, and minimum among them. Here's the results. In the segmentation scenario that causes the largest variance is the combination of city, category, and grid. And other several scenarios following closely behind also performs well. This can also be proven by observing the max, mean, and minimum graph below. There are segments growing super fast and also segments declining fast under these scenarios. We suggest that vendors take the top several scenarios into consideration and get a look in depth into different segments under them. We also provide a Jupyter notebook which shows the distribution under top 5 scenarios. Another point worth noting is that using a single feature as a segmentation scenario usually won't incur a large variation among different segments. This may be because such a scenario is too general and the resultant market segments are high level and may be growing or declining at a similar pace. Yet, the most effective scenario for single feature is city, which can also be proven by looking into the max, mean, minimum bar chart below. Let's go back and move on to the second question. The second question consists of clustering analysis. We hope that there is a way to find the best wholesaler and commercial value through further research. RFM segmentation is a great way to identify customer segments to be treated specially. People can use this method to improve their customer marketing. We were curious whether merchants could be described by using the classic models commonly used in retail industry, and thus makes the traditional analytical methods also works. At the beginning, we worry that since merchant purchase is a stable behavior, we do not know whether the recency feels still meaningful. We use the RFM method to model the data in the following steps. First, define and process the data. Recency is simply the amount of times its customer's most recent transaction. Frequency is the total number of transactions made by the customer during a defined period. Monthly is the total amount that the customer has spent across all transactions during a defined period. We select the data of the most recent year as the defined period. The second step is to divide the customer list into tiered groups for each of the 3 dimensions. It's recommended to divide the customers into 4 tiers for each dimension, such that each customer will be assigned to 1 tier in each dimension. We use these points to divide different tiers. Next, we use K-means algorithm to try to classify according to these features and display them on the graph to observe whether the classification has practical significance. We found that the removal of any of the 3 groups of RFM features could not lead to a good classification. It also proves that even if the merchant's purchase is relatively stable behavior, his behavior can partially reflect the purchase characteristics of the consumer. In the end, we found that dividing merchants into good merchants and ordinary merchants works best. Here's some visualization of the results. On the scatter plot, we can clearly see that there is an obvious data aggregation in some positions, and good merchants concentrated. These scatter points obviously reflect the information of geographical location and traffic artery. To prove this, we superimposed the scatter plot on the map to see that it is very close to our judgment. In order to reflect our hypothesis more clearly, we further took out the map of Iowa for comparison. It can be seen that our conjecture is fully verified. Good merchants are mainly distributed in major cities, major traffic roads, and border cities of Iowa state. It can be seen that RFM can be used to describe Iowa liquor merchants. This enables data consumers to generate more targeted policies, such as for merchants to select locations and for vendors to find the best target group for promotion and marketing. It is also worth noting that results of this part agree with the results in the previous part. Now let's go back and move on to the third question. Having known some strategy to choose market segments, locations, target groups, etc., we are now also interested in strategies to optimize the profit. So, if the business owner have limited capital and limited inventory space, which products would be the best ones to invest in or buy and keep in stock? That is, to find the products that give maximum profits, and at the same time, keeping in mind that the inventory space is limited. Here we try to find the list of top products of at least 3 months which has maximum profit margin. That is, sales price minus retail price. And at the same time are sold faster than other products, therefore giving the business owner maximum profit in less time. As the price of products keeps changing, we run the analysis for multiple quarters, which gives us a best idea of best products to invest in. We found that the products like HA something and Remy Martin Lewis can give profits up to 1,000 US dollars per bottle. Following graphs shows the top 5 products to invest in for several different quarters. For example, for the first period, we found that products like HA something and Remy Martin Lewis can give profits up to 1,000 US dollars per bottle. Selling just 100 of them, this bottle can give profit of at least 1 million US dollars in just 3 months. Also, despite the price, Remy Martin Lewis appears in top 5 products for all 3 quarters, which means it has been all-time favorite. At the same time, it has maximum profit margin. Therefore, it looks like the best product to invest in. And that's all about our project. Thank you for listening.